Hi everyone, I'm Sage, and I'm a Metrology Engineer here at Covalent. Today I'm going to share a story about one of my favorite recent catalysis projects that kind of our whole team had a role in working on. This project included characterizing an entire automotive three-way catalyst. At Covalent, we have quite a bit of experience, and it's very typical for us to analyze catalytic materials, but it's not typical to get an entire part where you can't isolate for any variables. Also, in this specific case, our client was actually more focused on performing computer simulations to do their part in modeling how these materials perform in the field. And they didn't know as much about the compositional and process information, which we typically have reasonable amount of information on that side from our clients to guide us on how to perform the analysis. So in this case, we had to carefully come up with and consult our client to make a plan on how to analyze this entire part. There were many parameters of interest that were all inputs into their model, some more sensitive than others. Ideally, we wanted to get a reasonable estimation on all of these parameters so they could use them as inputs into their model. Now, fortunately, we have a wide suite of instrumentation available in-house to analyze catalytic materials, including full chemical analysis capabilities, mechanical testing, optical and electron microscopy, as well as, very important for catalytic materials, a variety of particle and porous materials analysis instrumentations. In this case, in consultation with our client, we decided that it would suffice to get chemical compositional information from inductively coupled plasma spectroscopy techniques. We would also use X-ray photoelectron spectroscopy to get surface analysis on the oxidation states of the different platinum group metals that were present. And then we would use various different gases and specific permutations of gas adsorption techniques to get a lot of the porous material properties. So that included nitrogen gas physisorption to get the surface area, which can vary widely and is a very important property for catalytic materials. And it included chemisorption analysis with various different adsorbate gases that all interact with the different platinum group metals at different temperatures and in different ways, which are the key role that an automotive three-way catalyst is performing in the field. It's chemically interacting with different gases that are passing through the exhaust and reducing them to states that are better for our environment. So it's good to have a grasp on exactly how the part you're putting in an automobile is going to perform on those aspects. For catalytic materials, some important and very standard properties to measure are the surface area and the pore structure. This instrument is our workhorse analyzer that performs these tests. This is a gas physisorption analyzer, and it can perform physisorption with various different gas adsorbates at cryogenic temperatures, and it can do multiple samples at once, so it's very high throughput, and it's capable of determining the surface area and the pore size distribution, pore volume, and other parameters of all kinds of porous materials. So you can have very low surface area, very high. You can have micropores if you use the right gas, all the way up to hundreds of nanometers in diameter, very large mesopores. For three-way catalysts and catalytic materials in general, it's also important to know how they'll interact with different gases. Often this is part of their primary purpose. These properties can be studied using chemisorption, which this auto-absorb gas absorption analyzer is capable of. Here we have degassing stations, an integrated furnace for catalyst pre-treatment, as well as analysis chambers, all in one unit. In this specific case of an automotive three-way catalyst, we have various different platinum group metals present, which interact with different gases under different conditions, all coming through the exhaust pipe to reduce those to more environmentally friendly forms. So using the same instrument and consecutive analyses, we were able to perform different tests using the same instrument to get the oxygen storage characteristics, the metal dispersion, surface site density, and it's also capable of looking at things like water vapor absorption uptake, carbon dioxide storage, carbon monoxide interactions, nitrous oxides, and various other different interactions that can give you insight into these properties. If you're a manufacturer or user of catalytic or other energy adjacent materials, and you have metrology or characterization needs, please contact us through our website and we would love to work with you.